Hi, welcome back and thanks for watching again. My name is Arito. So today's video is going to be another DIY breadboard overdrive pedal build. And so if you're familiar with schematics and breadboarding and all that stuff, this definitely is not for you, so you can probably just stop watching right now. But if you're new to this stuff or if you're interested in breadboarding your own overdrive circuit, please tag along and I think you'll enjoy the video. But if you haven't watched my previous video, I have a three-part series. Well, it's actually mostly two parts, but I have a three-part series on how to build an overdrive circuit using a breadboard. And that is more of your typical quote-unquote overdrive circuit. It's kind of like a tube screamer, but not as crazy mid-humpy. And I think it's a pretty decent sounding overdrive for how simple it is. And so with that video, I walk through all the components that you need to buy to build it. And then in the second video, or part two, I go through how a breadboard works. And then we go through each component, plugging them in one by one. So it's going to be a very long, slow video. I think it's about 40 minutes or so, maybe more. But if you've never done this before, I think that is a good video to start, so you can see how we build up a circuit on a breadboard. Today, I'm not really going to go through each step of how to build it on the breadboard. So we will talk about the schematic and I will talk about the components that you need to build this, but I'm not going to do a step-by-step how to build this on a breadboard type of video. And also, today's circuit isn't going to be sort of a typical or pleasant sounding overdrive, but it's going to be a fun, unique overdrive using only two transistors, or we're going to be using what's called BJTs, which are bipolar junction transistors. These are your classic transistors, as opposed to something like an FET or a MOSFET. Anyway, those details don't matter much. We're going to be using only two transistors and a bunch of resistors and capacitors and some diodes to build a very simple yet somewhat unique sounding overdrive circuit. So what we're going to do first is we're going to jump into the finished breadboard, and I'll play through a Strat and a humbucker guitar so you can hear how it sounds. And then after that, we'll take a look at the schematic and I'll talk briefly about what's going on and also go through some of the components, and so you can build one of your own. So I hope you enjoy the video. Again, please share your thoughts in the comment section below. And as always, thanks for watching. Okay, so we are taking a look at this is the breadboard overdrive with the two transistors. Don't worry about this, it's going to come into play later, but it's not part of the circuit right now, so it's a true bypass pedal that I made, so it's not part of the signal at all. And there's a little switch, I don't know if you can see it, but there's a little toggle switch right here. In the down position, it's going to be the bypass signal for the breadboard, and in the up position it's going to be the overdrive turned on. So let's start off with the clean tone. I'm in the middle pickup on this Strat. Okay, and so we'll start off with the gain knob right around 9 o'clock, and let me turn it on. Okay, so pretty decent sounding overdrive, probably not as smooth as the other breadboard overdrive that we have, but sounds okay. And so let's turn up the gain, and we'll slowly hear how the tone changes throughout its gain knob range. Okay, so you see, obviously at max gain, it's very much like a fuzz or a really harsh distortion, and then everything in between. So we started off at 9 o'clock, where it was kind of a nice, crunchy, mild overdrive, through sort of a harder distortion, and then into borderline fuzz territory. So let's go back to, I'd say like 11 o'clock. Okay, and then let me turn up the gain even further to like 2 o'clock-ish, maybe. Okay, so let me turn up the gain to about 3 o'clock. Okay, and in the max gain sort of fuzz-like mode, if you go to the neck pickup and let's play up in the 12th fret region. So that was just a very quick run through of the different gain levels that you can get using a Strat. And another thing that I'd like to talk about is this pedal has low input impedance, somewhat similar to a fuzz face, although it's not as low impedance as a fuzz face, but it does have the same characteristics. Everything is at maximum on the guitar and my middle pickup, and it sounds like this. And so let me turn down the volume. We're at 10, and let me turn it down to 8. So you can see that there's a drastic difference in how the gain is, even with the gain knob at 2 o'clock, which is a pretty hard distortion type sound. It cleans up really quickly, really nice. And right now we're at 6. And we'll move on to the neck pickup. Again, gain is still at 2 o'clock. The volume on the guitar is at 6. Everything else, the tones at maximum. Okay, so you can see that it cleans up really nice. It doesn't go into that crazy glassy fuzz face territory, but it does a very nice clean sound just by turning down the volume knob. So we're still on neck pickup, volume is at 6. Let me slowly increase this back to 10. Okay, so I think it's a really fun, unique circuit that has a lot of different tones, going from a nice crunchy overdrive into sort of the saturated distortion, and then almost into fuzz territory, and then you can get all kinds of cleaner tones with the volume knob on your guitar. And so I mentioned that it has a low input impedance, which gives it that crazy cleanup with the volume knob on the guitar. But as a result of that, it does change its tone dramatically when you have a buffer in front of it. So if you were to have like a boss pedal in front of it, even with it turned off, it's going to sound very different if you were to have the guitar plugged in directly. But what I did do when I sort of designed, I didn't really design it from the ground up, but what I did do when I designed this was that it has enough range in the tone knob so that if you were to have a buffered pedal in front of it, you can compensate for that with the tone knob. So let's go ahead and demonstrate that right now. Okay, so what I want to do is this green guy right here is a pedal that I built a while back. It's an overdrive / distortion pedal, but with the toggle switch on the left as it is right now, it's a simple booster circuit. And so when we have this at a perceived unity gain or volume, it's just going to act as a buffer for anything that comes after it. But I just want to demonstrate how much the tone of this overdrive changes when you have this on. Okay, so what I want to do is first we'll take the breadboarded circuit out of the signal chain. And again, on the middle pickup, everything at maximum. Right? And so I'm going to turn on and off this pedal as I strum a chord. Okay, so maybe it sounds just a hair louder, so I'm just going to turn it down just a little bit. Anyway, so you can hear that it barely makes a difference in the tone of the guitar because it is a full frequency boost. There are very subtle tonal differences, and that is because of the way I designed the boost, but barely recognizable differences. Way more than what you hear right now. So let's turn on the breadboard transistor overdrive. Again, gain is at around 11 o'clock. So you can hear that it introduces a crazy amount of top end, and it sounds really harsh and bright and brittle. And again, that is because of the buffer. Let's turn this up a little bit more, go to like 1 o'clock or so. And okay, so again, really harsh and brittle and kind of unusable in a way. I guess if you're in a band mix, maybe. But so what we're going to do now is turn down the tone knob and get it to sound pretty nice. So I think that sounds pretty good. And so like I said, the tone knob or the tone trim pot was designed so that you can use this circuit with a buffer in front of it and not have any problems with that harsh brightness. And so that's about it. Let's move on. I'll just briefly do a quick playthrough with some humbuckers. If you're interested, build your own and then have fun with it, because there's a lot of possibilities within this. And then, like the fuzz face, or even similar to the original breadboard overdrive, tweaking certain values in capacitors and resistors is going to change the tone of this pedal drastically. And so that's another fun thing you can do with this. Okay, and so on to the neck pickup. So we're taking a look at the schematic, and if any of you out there saw this and said, hey, I know what you did here, you are right, and you must know your schematics very well, because what I did was I basically took the first two transistor stages from a big muff and then just cut it off right after the second transistor and added a very simple RC tone knob, exactly the same thing that we had in the breadboard, or the original breadboard overdrive. And so the goal of this circuit design is the same thing that we tried to achieve in the original breadboard overdrive, and that is to get a decent tone with the least amount of parts as possible. And so this circuit is a very bare bones, stripped down circuit. If you know your circuits and your schematics and all that stuff, you'd be looking at this going, hey, why didn't you do this? Why didn't you add that? Why did you leave this out, or whatever? And again, so the goal of this circuit is to be as simple as possible while still having a decent tone, so that if you're a beginner breadboarder, is that even a word? This would be something that you could do without having to go through too much trouble. And what I want to do is very quickly go through the circuit for those of you who are not familiar with the big muff circuit and what's going on. And then what I'll do is I'll put up a picture of the breadboard along with this schematic. What I'm going to do is just highlight each section on the circuit and the corresponding section on the breadboard, so you can compare the two and say, okay, so this resistor is this thing right here, and so on and so forth. I said that I'm not going to go through what I did in my previous breadboard video, where I plug in each resistor one by one and walk through the whole entire build. But anyway, so let's go over the circuit real quick. So basically you have two transistors, and these are the symbols for transistors. The first one you see here is an input amplifier. So this takes the incoming signal from the guitar and amplifies it. So right after that you have the gain knob, which is actually just a sort of a volume knob in a way, because all you're doing is attenuating the signal, so changing how strong that signal is as it goes into the second stage. So you're not really increasing gain per se, but you're just cutting off the signal and changing how much of that signal goes into this second transistor stage. And this is where all the overdrive happens. So it's another transistor amplifier, but if you look up here, you see 4 diodes. And so these are 2 a pair in series. So it's kind of like having a typical symmetrical clipping, but mostly you see only 1 per side, or so 1 going in each direction. Whereas with this, I put in 2 going in each direction, because with only 1 going in each direction, meaning you only have 2 diodes total, the signal gets very compressed and saturated, which works great for the big muff. And the big muff actually has 1 more of these right after this, so it double compresses and saturates the signal, which gives it that creamy big muff tone. But we wanted to keep it somewhat of an overdrive, so I added 1 pair more, so that we have 2 diodes in series going in either direction. You can add LEDs in here if you wanted to. You could add germanium diodes if you wanted to, and that's definitely going to change the tone. So this section right here is going to do all the clipping. Okay, and so coming off of that, we have again a very simple RC tone knob. Like I said, this is exactly the same as what we had in the original breadboard overdrive. It's just a resistor, in this case a variable resistor, and a capacitor going to ground, and it's going to cut off the high end, and the cutoff point is going to change depending on where you have that tone knob. And from there we go into the output level trim pot. The circuit itself doesn't have a whole lot of output volume, so we're not going to be able to use it as a boost or anything like that, but it is somewhat loud enough that I think if you crank to the output level, it will push your amp a little bit. Anyway, so that is the circuit. There's so much that you could do to this circuit by changing resistors and capacitors. Again, changing the diodes to change the clipping tone. Play around with this, and you could eventually build a big muff if you wanted to. I'd say we have about 40% of a big muff right here, and that's why when we crank the gain knob, it really did sound a little bit like a big muff. That saturation and sort of that creamy smoothness that you get. So one of the things I want to point out is I mentioned a little bit in my humbucker playing samples that this circuit as it is has a little too much overdrive or saturation with the gain knob at 9 o'clock if you're using humbuckers. And in there I say, well, you can change the gain knob to a 100k ohm, so 100 kilo ohm pot, to get it to sound a little bit more overdrive like or less distorted. But what's going to happen then is that if you're playing a Strat, you'd probably have to crank the gain up to, I'd say, maybe 11, maybe 12 o'clock to get a decent overdrive, and then at 9 o'clock it's going to sound slightly broken up, clean, yet a little bit muddy sounding tone, which I didn't like too much. If you are mainly a humbucker user and want to have sort of that cleaner, more overdrive like tone, definitely change this to a 100k and you should be fine. The transistors that I used for my build were two SC2240s. These are Japanese transistors that were made by Toshiba, and they're very classic, readily available transistors, right along with the 2SC1815, which is probably the most common BJT in Japanese electronics. Although I think they are no longer in production, so they are getting hard to find brand new, but you can still find these pretty cheap within Japan. One more thing to be careful about, the transistors never had really an international standard on how the leads come out, so there's going to be variation from transistor to transistor, and I'll put up a picture of the 2SC2240 that I used and its leads and which lead corresponds to the base, the emitter, and the collector. But whatever you're going to be using might be different, so you want to look up online the datasheet for whatever transistor you're using, and hopefully you should be able to find it. Once you find it, make sure that you check which lead is the base, the collector, and the emitter, and plug those into the breadboard into the corresponding slots. And so that's it. I think that covers everything. And so right after this, I'll show the schematic and then show the corresponding section on the breadboard so you can get an idea of how to build it. But again, there's so many possibilities that you can mod this circuit with, and so many things they can do to have fun with it. So if you do decide to build your own, definitely go beyond what I have designed here, because again, everything about this is simplicity with the least amount of parts as possible. So you can build a bunch of fun stuff based on this and sort of develop your own fun circuit. And definitely share your experiences with us in the comment section and let us know how things go. And if you are able, definitely post a video of your finished product and play through it. But I hope you enjoy this circuit, and I hope you had fun building it. And if you have any questions, or if you have any requests or whatever, please share your thoughts in the comment section below. And as always, thanks for watching.